Okay, should be live now. Okay, so welcome for joining again in our monthly query research progress update. So yeah, our high-level goal is still the same as before. So we do research on hiding the complexities for reading and writing over decentralized environments, and we mainly do this by making use or by introducing new querying technologies that help in building such a query-based abstraction layer. So it's still the same people doing research in this area with these topics. So the plan for today is the same as always. So 3 slides per researcher. The first slide, the high-level goal. The second slide, accomplishments of previous months, and then the third slide, the targets for next month. And each researcher will talk about 5 minutes or so, and then after each researcher, we'll have a short discussion moment. But before we get started on the different researchers, we'll have our special guest for today, Kush, who is also a PhD student here at Ghent University. And for that, I will switch over to his slides. So Maarten, please let me know if the slides do not switch correctly. But you should now be able to see his slides. Is that correct?
Yep, yes. I can see them.
All right, yeah. Perfect. So Kush, over to you.
Yeah. So hello everyone. So I'm going to present my work that I'm currently doing for reusing the stream queries, optimizing stream queries, and also reusing the aggregated results that you have in different stream queries. So first of all, I would like to give some background on RDF stream processing. So RDF streams are basically RDF graphs that are annotated with a timestamp, and in an RDF stream, you can have multiple such RDF graphs with a timestamp that can occur at different time zones. And a stream basically is infinite, and you can have different such RDF graphs, as you can see in the figure, like the blue and the green. They can be different RDF graphs. So since the stream is infinite, you need to have you need to process those streams. So you can use windows. Windows are basically finite chunks that are defined over the stream, which helps you define a particular chunk that you can process. There are basically 2 types of windows. One would be a time-based window, and another would be a count-based window. So you can see that the time-based window can define it as based on time, that okay, the size should be 20 seconds, and after the 20 seconds is passed, then that exact chunk is evaluated. And for count-based windows, you can define it as that a particular window, if you see 4 green values, then that particular window is then evaluated. And to query and define such windows, RSP query language is used, which is basically an extension of Sparkle with the extra specification of window semantics, so that you can specify how big your window would be and the sliding mechanism as well. An example for it would be, for example, if you want to query average temperature over a stream, then you can do it like this. And here you can see with the range and the step that this will give you the average temperature of last 30 minutes every 15 minutes. So now,
can we ask a question?
I think now, after because I have 10 minutes, I'm not sure.
Yeah, up to you how you
can ask questions.
Okay, can you go to the previous slide? Yeah. What EX stream mean?
X and just sorry, yeah. The prefix should be EX. It's a typo, I forgot.
Okay.
Yeah.
So it's just a predicate to tell you that this is a stream.
Yeah.
Okay.
Yeah. So use case would be that you so to reuse streams over in a decentralized or distributed environment, you can already have different RDF stream processing engines that are querying some stuff over the different data sources. For example, here you can see that there are 4 different RSP agents. One is calculating the average over X, another is Y, Z, and another is average heart rate. And there is another parent RSP agent or a new RSP agent that's introduced into the network that wants to, let's say, calculate the calorie counting and further use that calories to do some anomaly detection. So with the formula of calorie counting, you will have to reuse those streams. So the goal of my research is to see how you can reuse the streams to create, to calculate the calories and then further do anomaly detection. Yeah, so the results of the queries which are already running can be reused to optimize the execution of other queries which are later introduced. And yeah, to see that there are similarities in the queries, you can use query containment or query isomorphism. Query containment is basically that if you have 2 queries, the result of one query will always be a subset of the result of the second query. And query isomorphism is that the queries are structurally identical and will produce the same results. Now, if you have a set of RSP agents and you have their queries,
what is the difference between query isomorphism and query equivalence?
So the query isomorphism is a stricter relation because it checks the basic graph pattern or checks the graph. But then for query equivalence, it just means that the 2 results should be similar.
Okay.
So you can have, let's say, 2 different queries. For example, if they are both, let's say, doing an output of 5, so they're equivalent, but then the structure can be different.
Okay.
Yeah.
So it's more syntactic, quote unquote.
Yeah, and it's more stricter as well.
Okay,
Yeah.
I see. But why you don't do equivalence instead of isomorphism in your content?
Yeah, because you cannot really predict the data by itself because you're not sure how the data would be. So with the query isomorphism, if you have 2 different data, so if you have 2 different queries, then you can see similarities in between them. For example, if I'm, let's say, querying for average temp, for query equivalence, the results are they depend on the data as well.
I don't think so, because I think query equivalence, it means usually that is Q1 is contained within Q2, but basically that you have query containment, but both way.
I think it's query isomorphism.
No, it's query equivalence.
Okay.
I'm pretty sure usually it's how it's defined.
Okay.
But I'm not sure about query isomorphism. I never looked into it.
Yeah.
Because it's supposed to be query database independent.
Okay. Yes, maybe the query isomorphism that I'm doing is query equivalence, but then for me, how I understood was that with query equivalence, I was thinking, for example, if you have, let's say, a sensor that's doing there are 2 different values and they're calculating different things, but if the results of both them are 5, then the queries are equivalent because the end result is 5, but then I cannot really say that the queries are similar because one is, let's say, calculating average temperature outside and one is, let's say, calculating average temperature inside. So the sensor that they will work on would be different, but then if the results are the same, then they would be equivalent. So that's why I wanted to use more based on the structure of the queries.
Okay, I think I see what you mean, but it seems to me that inside of your container algorithm, the source should be considered. Because what you're saying is that it's because you have different sources, right? But one source is from one sensor. I just think that your algorithm should consider that, but I'm not pretty sure.
Yeah.
Thank you.
Your query isomorphism, here, it's based on the basic graph pattern or on the abstract syntax tree of the query?
It's based on the basic graph patterns.
Okay, so for instance, it doesn't take into account a filter.
It doesn't take into the filter.
No.
Okay, thanks.
So yeah, so after you can use the query container relationship to see that the queries are similar and can be used in the bigger query. Let's say, for example, here you have 3 different windows, and you can do a union operation to result for the parent query. And the important thing to notice here would be that the window size of the child query and the parent query are the same. That is all from 0 to 60, and you can easily create a result for the parent. But if you have different window semantics, it's not possible to simply merge, because let's say here you have one window of 0 to 35, one 0 to 10, and one 0 to 50, and then the parent query is 0 to 80. So you can see that you have, let's say if you have the 3 different streams with the windows that I showed in the previous diagram. So this window will trigger at 35, and the second one will trigger at 10. And let's say when this triggers, then there is no result that is available for both of them. And let's say when the third window, the window from the third stream triggers, and at the same time there is no result from other places as well. So let's say if a new query comes that wants stuff from that has a window of, let's say, 0 to 60, then it has to either combine all of this, and there is also possible data overlap in between the windows. So one simple solution would be to just use approximation to kind of approximate the values and approximate the results. So the aggregation functions are a loss function, so you cannot really retrace back the original data set. But then the problem with approximation is that it can be far away from the ground truth, and it's not really dependable for critical use cases. And you're also not really sure how far it is away from the ground truth. Like, for example, for some aggregation functions like average, it can work. But let's say if you're doing for minimum or maximum, then it's rather tough. So to get dependable, correct results, should we just not use approximation and just rather query the original data source and build it on client side? What other thing you can do is to use chunking strategies as a solution. So you would register a new query based on and define new windows. The new window would be the chunk based on the chunk that you have. So, and then the chunk is defined by the greatest common divisor of the range and the step. And here you can see that that the chunk size is 5, and so you register a new query with the different for the different stream with chunks, and then you can later recompute aggregation results with this. So the benefit of it would be that you don't have to query the whole data set and query it, but rather the same RSP agent can evaluate in the chunks, and you only get the aggregation result that you have to merge on the client side for the parent query. And you can also, like in some aspects, you need to register a new query, but sometimes you also don't need to register a new query. Let's say if the greatest common divisor is the same as one of the window sizes of the first query, then you don't need to do that. Now, what about the aggregation functions? So as I said before, that you can register a new aggregation, that you can register a new query with the same aggregation function as the parent query. But what you can also do is that you can kind of use the different aggregation functions to derive another aggregation functions as well. So for example, if you see Sparkle 1.1, if you have count and sum, you can derive average. If you have average and count, then you can derive sum. And yeah, if you have min and max, then you can compute the range. It's not Sparkle 1.1, but then it's an important aggregation function. Communica also supports support for extension functions, and when you can also define extension functions which can also reuse the existing values as well. So that thing that you add is like if you have sum count or sum of squares or square root, then you can calculate variance or standard deviation. If you have count of distinct values and count of all, then you can count the duplicates. Yeah. So to do all this, I'm making a microservice called Streaming Query Hive, where you can define multiple streaming windows and their sources, and you can define a parent query that then it uses the best. It has different operators, and it does check which operator is best to use, and then it will output a single parent query that reuses the different streaming queries that are running. So an example architecture for it would be that, let's say if you're using something as MQTT, then the three RSP agents are sending the results to an MQTT broker. And and then the parent RSP agent checks query containment between the existing queries that are running and the query that it has. And it subscribes and fetches the results and then computes the new view on the client side, on the parent RSP agent side. And then further, you can also do anomaly detection or changing by just adding a reasoner. And then you can get another reasoner output stream.
So this will also do the chunk
Yes.
approach that you.
So this will also do the chunk approach. So for example, this example is for, let's say, if the windows are the same, so it just fetches the results. But let's say if you have to have new chunks that you need, then the parent RSP agent can request another query, like can register another query in the RSP agents, and that will give the result stream on the new topic where you can subscribe again and then compute on client side. So, you have any questions?
I'm not sure I understood why we need to do approximation.
I'm just saying, introduce approximation as one way that you can do it. I mean, you should not do it because it's not the ground truth. But then the benefit that approximation has is that you don't have to register a new query, so you can really reuse the same query for. Yeah, you can reuse the same query to kind of have an approximation. So for example, let's say if you have a non-critical use case, for example, let's say how many people are in a room. So you don't really care if it's 25 or 28. You can work around with if it's like if you know that okay, if it's more than 20, then you can do something. So you don't really, in use cases where you don't really need the exact value, then approximation can be a benefit, because then you don't have to register a new query, because there is always extra resource overhead with registering a new query.
But because I'm not foolish, basically you already have a query result at a specific time that is exact, and then you at a later time you don't want to register a new query, so you sort of look at the previous result to see how it would have changed based on the facts.
Let's try this one.
So we sort of predict what the future would be based on previous results.
So for example, here, let's say, you have a window from 0 to 35, and the second window, so let's say from 0 to 35, you have the value, let's say 10. In the second window, if you're doing average, you have from 10 to 45, let's say you have the average 20. And then if you have to combine with something else, let's say 0 to 50, then you'll have to align those two windows and then minus the overlap. So you have 0 to 35 and 10 to 45. So to compute from 0 to 45, it would be the summation of the values minus the overlap that you have. That's the seconds seconds multiplied by the average value of the both windows, and then you will get the one value of 0 to 45. But that's basically an approximation, it's not the exact value. And then again, if you have 0 to 45, and then you have to add it to another window, let's say in the stream 3, that is 0 to 50, you still need, so you're combining 0 to 45 after approximation, combining with another window that's 0 to 50, you're still missing 5 seconds of data. Then you can again approximate that, okay, this 5 seconds of data, so the average value of 0 to 45 was X. So the 5 seconds would be X by 45 into 5. And then you add that to the 50 to kind of approximate the aggregation to kind of join the streams together.
But I guess what I'm not sure, that what I'm not understanding is that why the query engine would be doing this approximation. Why don't the application, instead of registering a new query, look at its previous result and sort of, approximate something itself? Because it seems weird to me that the query engine seems to me like it should give you exact result or at least some sort of uncertainty. And I think that the application should be the one that define how they will do that.
Yeah, maybe we can keep the question offline because we're running a bit out of time. But thanks in any case for your presentation. It's nice to see what kind of complexities that arise when streams and time windows are introduced in a querying context. Because most of us do querying on pure static data, except for Maarten, of course. Mm-hmm. But with time windows and streams, you go much more in that direction. So let's go ahead. Yeah, my pleasure. So let's switch back to our other slides. I'll have to go out of full screen for that. No, it's this button. So let's go to the normal agenda again, and we can go to Ruben. So Ruben, what did you do?
All right. Well, my high-level goal is still the same. I want to do client-side optimization based on the sort of belief and also the support for it in literature that clients exhibit patterns in the way they use the engine. So we can use this for prior knowledge, basically. What I worked on is reworking the paper where we investigated link prioritization in structured decentralized environments like Solid. I fixed various issues and had to rerun some benchmarks with more algorithms. And there were actually quite a few issues that are pretty major. I've looked at the data, I don't have it ready yet, but it seems to be more logical now, but I think the conclusion is still the same, where prioritization doesn't really work that well. And especially in Solid Bench, where only the last 2 discover queries are show a lot of traversal. That is where actually an Oracle algorithm can improve things. Then I worked a bit on join sampling and seeing how that performs compared to base Communica. And in conclusion, the short conclusion is the produced plans were pretty good, but base Communica is already very good with the bind join, as it sort of greedily finds the best plan it can make, basically. But as the bind join is not a binary join, we can look into replacing the multi-smallest actor, which is the sort of multiple binary join actor. And here we actually outperform them in terms of query plan by quite a lot, orders of magnitude. But the runtime of the query plan is still inefficient. This is probably an implementation thing, but that's what I figured out so far. And then to query or to benchmark these caching approaches, I want to make a sort of real-world inspired query sequence benchmark. I've been doing a lot of literature review to see what patterns exist in real-world applications, and I'm working on defining a sort of generation approach that follows a model that is inspired by these patterns that we see. So on to the next slide.
So it's a query sequence approach in a social media environment.
Yeah, yeah, it's an extension to solid bench. And well, and I'll also be using live data, probably do some updates or figuring out how to do it. So yeah, my next targets are pretty simple. I want to finish the paper, obviously, for ISWC. Most benchmarks are done. I saw one small issue, but it might be a data copying thing from one code base to another. And I need to still update the writing a little bit. Most of it is done. It's probably a day's work if the data is there. Then I want to finish defining this model that we use to generate these query sequences. Not yet implemented because I'll need to look into how solid bench works, but at least have it sort of on paper with citations to show where I got it from. And then finally investigate the sort of inefficiency of doing joins when using a join sampling generated plan. This requires some investigation into what is the difference between these plans, because it's likely a binary join selection issue where an inefficient algorithm is selected compared to base communica due to some changes in the cardinalities. That's my best guess. So if there's any questions, shoot.
Any questions for Ruben? So what are your long-term goals with this joint sampling approach? Like, if you would find that there's an implementation issue, like what are the next steps you want to achieve with this line of work?
One is looking into if I can replace, in some cases, the multi-smallest actor with the sampling, which is possibly an improvement. And in general, I want to sort of get why joint sampling does or doesn't work, and maybe see if it can perform well when using joint sampling over the cache in Ghent traversal.
Yeah.
But it is sort of lower on the priority list due to the sort of efficiency of communica already.
When
So
you
I
say,
guess-
sorry.
No, to finish my thought, so I guess with that line of work, you will also probably have to do an analysis of the trade-off between the benefit you get from joint sampling, but also analyzing the cost, because if I understood correctly, for the joint sampling, you need to index slightly more data, right? Or is that not the case?
I am reusing the sort of communica indexes.
Oh, okay, so there is no additional index needed.
No, it's just that you need to use a different index that enables random sampling, but it is still the same indexes.
But then the indexing approach is different.
But the index is the same, but the way you use the index when sampling is different compared to doing actual joins or looking up sort of entire.
Okay, so the amount of data you store is the same.
Yeah. It should be.
Okay. So then there is no cost, right? There's only a potential benefit.
Yeah, but yeah, the sampling costs, like the sampling costs can be quite high because you need to sample joins. But then, yeah, my current implementation, my current implementation is very efficient also in the way it samples, because it doesn't look at the size of the input chirp pattern, just does like a certain amount, like 1,000 samples.
Yeah. Okay. Fabian, you also had a comment or question?
Yeah, it's slightly overlapping with what you were asking. So when you say the joint sampling is not efficient, is it actually due to the overall, let's say, approach of sampling, or is it linked to the strategy that I use either for the prerequisite indexes or for actually performing the sampling? In other words, do you think there is room in improvement if you change strategies at this different level?
So the sampling itself doesn't take that long. It's still inefficient, so there's still a lot of room for improvement for selecting how many samples you take for each join, which based on how interesting they seem. But the sampling is at most for, I think, 10 triple patterns, it takes 0.4 or 6 seconds. The main inefficiency is in the way afterwards, after I sort of create this tree of plans, where Communica selects the binary join algorithm, like the hash join or the multi or inner loop join. That one is probably why the actual execution is inefficient, but the plan itself is good in terms of intermediate results produced.
Okay.
All right. If no other questions, let us move to Bryan.
So my high-level goal is to optimize traversal queries using the explicit data publication structure. So it can be, data provider can provide some structure to document their data set, either to improve query processing, to foster greater interoperability, or for licensing or other things like that. So I want to be able to exploit that while I'm doing traversal queries. So we can go to the next slide. So first, I've reworked my ISWC paper. So I've created this separate document to provide some proof about the time complexity. It wasn't really asked by the reviewer, but something that I wanted to do because I felt like it would be a bit more serious if I had that. I've also improved my running example and some of the tables that I present in the paper. I've also started to work on doing query planning using the shape index approaches, which is what I talk about inside of the ISWC paper. So I started by updating my implementation to the latest implementation of Communica, and I've also explored what I want to do. So the first thing I would want to do for query planning would be to cache the shape index that I encounter in the network, and then when I will perform another query, I would evaluate those shape index to do some join pruning, and also do my source selection. So it will be basically in two steps. So first I will do some sort of federated query, and after that I will do my actual traversal in the network. I've also worked on facilitating the querying of heterogeneous vocabularies using rules. So I spent a lot of time to fix a bug inside of the streaming sort because an event wasn't cast, and I needed also to change some unit tests. It was a bit difficult to find this bug, so it took me a lot of time. And lastly, I work on using materialized view for federated query to improve their performance using query containment. So one thing that I've done is that I explored the semantic of those queries. Because most query containment algorithm assume set semantic, but Sparkle is back set semantic. And if we are doing federated queries, then the semantic might be different. And if you are doing, for my experiment, I saw that if you are doing federated queries without service clause, then we have a back semantic. But if you are using a service clause, then it seems to be a back set semantic. But I need to explore more why it is back set semantic, because I can see it from the algebra that it seems to make sense, but it's still strange that without the service clause, then they are back semantic. So I need to explore more how it is formulated without service clause. I also made a library to exploit remote cache of queries, so exploit those materialized view.
Maarten has a question.
You can go.
Are you talking about the results being back semantics or the query itself being back semantics? I guess the result, right?
Yeah, the result.
Oh, yeah, okay. Go on.
The Sparkle language can produce back because it has back operators, but also in the normal, a knowledge graph is set semantic. But if you are doing a federated query, it seems to make sense that in some situation it will actually be a bag and not a real knowledge graph. It would be.
But even with even if the data is set semantics, Sparkle can still produce bags with yeah, set semantics in the data.
That I know, that's why I said it's back set semantic normally. But if you were
What
to
is
have
bag set semantics?
your operators are back semantic, but your database is set semantic. Because a knowledge graph cannot have duplicate by definition. So it's a set.
And so for instance, a construct would be a set semantic also in the result.
Yeah, because you produce a knowledge graph.
Yeah. But a select can be a back semantic.
Yeah, because of the Sparkle, yeah, the bag operator. It's just that when we are doing a federated query, it's unsure if you really have a knowledge graph or if you have something else that can allow a duplicate. And it seems like without service clause that it's not a knowledge graph because it has a duplicate, but with service clause, at least for my early experiments, it seems like it's a knowledge graph.
Well, yeah, I think I'm aligned with you. I don't see the impact of the service clause because normally, the impact could be because
you
the
could have
service-
overlapping data.
the service clause itself is the result of a query, so it's a back semantics.
Yeah.
So
No.
the intermediate result would have a back semantic compared to and let's say a name graph, a local name graph source, for instance, which would have a set semantic. That could be the reason.
But because what I want to explore basically is that if I have because you can only get back semantic into your result if you have projection. And I want to explore if I don't have projection, can I still get back semantic if I'm doing federated queries? Because I'm querying different knowledge graph, because it really depends how federated queries are defined into Sparkle. And without service clause, we can have this. So if you make a separate SPO query with no projection, you will get duplicate result if the data sources are overlapping. But if you add service clause, then you don't get that, at least with normal cases. And I want to explore if it's really the case or if my example are just too simple. So I need to understand more how it is defined without service clause to see if I can reproduce it with service clause.
Yeah, I think you will be able to find such examples because if the same triple is available into Sparkle endpoints, and then you build a Sparkle query with service clauses to get those triples from those two endpoints, you get the same triple twice, so it would be a bag.
At least when I did simple experiment, I wasn't able to get that.
You would join the bag away, right?
This is why I think this is why, because they find that one.
Yeah, they are selected from two places, and indeed you would join them. But it would, well, it depends how you select your variables, of course. If they are the same variables, yeah, they are joined. But I think you will be able to find such an example.
Yeah, I also think so, but I thought that it would be easy, but with simple example, because I wanted basically to also show that it's sort of realistic-ish, to just so that it's actually a real problem. You don't need to make an obscure stretch query to do it. And
yeah, but if you have different, so if you have the same triple from different federated sources, will they also not have a different graph? Because they're part of different graphs. So you can use the graph node to see the difference.
I don't know how graph are defined in federated queries, but I'm just using data set with default, the default graph. But because I'm guessing that then you get quad, so it's not the same thing, but I'm not sure how graph work with Sparkle, to be honest.
Can I still, like you said that it depends how you join, but that's all under the hypothesis that you don't do a projection. So then you would always join. Because if you don't join it, well, then you would have different result in your projection because now you have an additional variable where you would differ. So I do feel like I think that it's true. And then there you think that it's not true. So the research makes sense.
Because it will really change what we want to do, at least in the theoretical standpoint. If it can become just back semantic, because it becomes a more complex for a problem. And yes, so for my next target to submit this the paper to ISWC. I want to continue my caching approach for query planning with the shape index. I want to finish the unit test for my schema alignment algorithm because it's mainly done. I need to do some unit tests and then to create a demo with SolidBench. And I also want to explore a more comprehensive entanglement regime and how to do some incremental maintenance for my reasoning. But I think I will not have the time, obviously, this month. I will probably just start creating the demo. And I want to continue my query containment solver. And we can go.
I was thinking that in the first slide you said that you will see how the data set are described at the sources. Is there a W3C or like some sort of recommendation how you describe, like people describe their data sources? Because if somebody describes it in a different way that your query planner or your algorithm doesn't know, how would you reconcile that?
Because right now I created a shape index to describe decentralized data source. I think I could also use void description, and there is also some histogram kind of summary that can be done. So I will try to support multiple of them, and so try to evaluate which is better for query processing, because my research is in query processing and not, I don't know, interoperability or something like that. So I just want basically to show that if you publish that, you have maybe this benefit for interoperability or documenting your data set, but you can also have some benefit from query planning. This is sort of what I'm trying to explore. So I'm trying to see basically summary method that are not just tailored for query optimization.
Okay.
One quick question. You mentioned both. You mentioned caching. You mentioned indexing, and you mentioned materializing views. So just to be sure, I understand the relation between them. Your idea is to pre-calculate and materialize views from what is indexed and what you see in the logs of the queries, in order to reuse these views when they are contained in a new query. Is that the idea?
Because it's actually sort of three different projects. Maybe I wasn't really clear, but because the overall goal is to use those metadata published by data provider. But one project is about materialized view, another project is for link traversal using shape indexes or something like that. So they are kind of not related, but in both of them I'm still using query containment or variants of query containment to solve those problems, but they are it's not as
because what I was thinking is that if you have indexes, whether they use shapes or not, would that make sense to derive definition of views from them, to materialize them in order to be more efficient at the query time? Or not?
I think it would make sense, because I think the approach right now that I want to take for query planning would be to first do a quote-unquote federated query, so explore this index and get sort of statically this information, and after that do a traversal. So I think if I understand well what you said. Because the overall vision is more about using those artifacts from data provider, and it's not about combining those three things together.
Okay. Thank you, Brian.
Thank you.
Okay. Who is next? It's Jonni. Over to you.
Okay, so my goal is still to investigate adaptive client-side techniques in a way that would allow for a portable optimization client-side, so things that wouldn't be tied to a server implementation. It's
kind of not really going in that direction because I use, for example, void descriptions and stuff, so that those are actually server-side things. Yeah, what I worked on in the last month is I fixed the HTTP request count tracking in Communica because there was a bug because of some changes a while ago, and I wasn't aware of how they affect the count tracking, so it was reporting way too high HTTP request counts for everything. But that has been fixed in the master branch, not yet released, I think.
Yes, since this morning.
Ah, okay. So it is released. Then I have a lot of updates and stuff to do in my experiments. But yeah, I also added the cardinality estimation to SPARQL sources. So previously it was doing count queries. So now if there's void metadata available from a void description, then it uses that to estimate triple pattern cardinalities, and it also breaks down larger operations, for example, a projection with a few patterns and stuff into basically individual patterns, and then tries to approximate the overall cardinality based on those pattern cardinalities. And then it also caches the count query results. So if it would previously have done the same, basically the same like count queries for things that contain patterns or operations for which it already did a count query, then instead of sending a new one, it can use the cached result of the smaller operation to estimate the bigger one. And then there's also a link filter implementation for link traversal. And then I also did some solid bench stuff for my experiments and also to just clean up the repositories. And then I updated my join and restart and bloom filter implementations for Communica version 4, which took a while. And then I also was collecting some Wikidata queries for experimentation, basically to see how federation works in practice with an actual endpoint that has rate limits and stuff. And then I updated all my experiments for works that have been published and for works that are going to be published for the latest runners and stuff. So yeah, that's what I did. And my next plan basically is to first finish the I run into some issues with my benchmarks, so I have to fix those today or tomorrow so that I can get my camera ready done by Thursday or a Friday morning. So that's my goal. And after it, I will look into some simple hybrid tests with solid pods and SPARQL endpoints with Communica. And then also, yeah, finish the Wikidata stuff. And then also, well, I have to rerun the experiments before the end of the month, and then expand my join restart experiments after it for a general version of that one. And then a lot of writing to do. So yeah, that's my plan for the next month. I hope to have everything finished by the end of next month, but nothing ever gets finished when I say I'm planning to have it finished.
But now it will be.
I hope so, yes.
All right. Any questions for Jonni?
No, maybe just making sure. So you have a nice publication plan. The paper on the benchmark itself is one thing, but I was wondering, since you are investing time in actually building the data set, your query collection for your benchmark, there may be a resource paper to be identified. I don't know if it's one of the three you had identified, but if you spend time in building a data set like this one and curating it and making it a golden truth, then there may be an opportunity for you to publish a resource paper on that.
Yeah, that would be great, but most of the additions are relatively small. I am basically building on top of a solid bench by adding things like Bloom filters and void descriptions to the data already is there. So there's not much room for a resource.
I understand. It's too incremental. I understand. Okay, thanks.
But thank you for the idea. Maybe one day I will have my own benchmark dataset, but not today.
And how is the Wikidata query collection going?
It's going okay. I have around half of the queries from their federated queries example page cleaned up and prepared. So basically, I'm taking those queries, making sure that they all look the same and that there's nothing like because there's some inconsistency in the casing of the operators and stuff. So I'm just cleaning those up because they annoy me, and then I'm removing all the service clauses from those, and also all the duplicate patterns after the service clause removal, and then
and the query hints as well, I guess.
Yes, like the engine specific ones, and then making a basically identical set of queries from those. And after that's done, I will. But it's kind of halfway. Yeah.
And have you executed any of them already?
No. But
once you do, I'm curious to see how they go.
I'm going about the rate limit because Wikidata is really strict with the rate limiting, and then Communica has a tendency to send a lot of queries.
But so, if I understand well, you are spending quite a lot of time curating these queries, right? You're building a collection.
There is I don't know if you can call it a collection, but Wikidata has a page with a lot of federated queries.
Mm-hmm.
I don't know where they actually acquired them from. I have to check when I'm writing the paper. But they have these examples for how to take this query and split it up for when they move the publication graph away from the main graph. So that's basically the federation that I'm looking into, and then how to, instead of doing the federation with service clauses, how to do it in Communica. So I'm taking their existing federation examples and breaking them basically, or like reducing them down to non-federated queries, and then trying to use Communica to automatically federate those.
Okay, and for each one of these, are you documenting what the query is doing as an English question? The reason why I'm asking is that then you will probably be having a resource which is interesting for the qual community, because you will have examples of question in English and their translation in a Sparkle query before any federated engine, and that's the resource that is useful for the qual people, for instance. The question answering over linked data, sorry. They are always looking for collections of question query collections, because their task is to translate from an English question to a Sparkle query. And so if you are curating queries on that, and actually at the same time you are documenting them in English, then you will be providing a potential resource for them.
Yes, but the documentation has already been done on the Wikidata page.
So it's good, because when you're going to release it, it's a dataset ready to be used for a challenge at Quad. That's what I'm saying. You may want to make it visible and citable and so on, because they may want to pick up such a resource to define one of the next challenge.
Maybe I need to look into it. But I really don't want to just take queries written by other people and then
Well, there is a high chance that Wikidata is under some Creative Commons license that you can apply to yourself on whenever you release your resource. And so it's probably a CC by SA. You put a CC by SA and you say you have reused the Wikidata one, and you are fine.
Yes. but is it ethically? Like that's
Well, you just you say that you build on top of the master queries.
Yeah.
Ethically, exactly. Ethically, if you say that you have reused them, that's what the CC by SA requires, and that's good. You're all good, and this is ethically and legally perfectly good.
Yep. Then I will look into it. Thank you.
When you said the rate limiting of the Wikidata, so what do you mean, like querying their own query service?
Basically, they have a public Sparkle endpoint, and you are allowed to, like I think it was a combination of IP address and user agent string is allowed to have a query execute at the endpoint for 60 seconds every 60 seconds.
Why, like you can also download the Wikidata, and why don't you host your own Sparkle endpoint which has no rate limiting?
Because it's
that's the whole thing we want to avoid.
it's quite a lot of data.
Yeah, it's very costly to do that. But yeah, if you can do that, then that's a lot better, of course. But if you cannot do that, then yeah, what Jonni is doing is trying to figure out ways to still execute your queries. All right, we're running quite a bit behind on schedule, so let's continue with Maarten.
Okay. So my high-level goal is to optimize decentralized querying using aggregators with incremental processing. Again, aggregators are like a component in the solid ecosystem, or just the decentralized ecosystem that's perform stuff transformations beforehand, and I'm investigating querying with incremental processing then. Last month, I think I had real trouble actually discovering what I did last month. But the main stuff is that the decomposition paper, the query decomposition paper from a thesis student of ours was accepted, and the camera ready version has been submitted now. Yeah, this paper, I think I said it last time, but I wasn't really sure. It's about trying to decompose a query into different queries so other people can reuse their results. This already existed, kind of, but most of the time they use heuristics based on the data or the other queries if they are available. And what we try to do is like a zero knowledge, where you actually don't know what the data will be and you don't know what the other queries are, but you still want to make sure that the query is decomposed into subqueries for better reuse. We did this based on unions, so we decomposed the queries on unions. And I guess in the paper, we described everything, how we did this and the algorithms. And if you actually want to decompose based on other operators, you could still, reuse everything that is described in a paper, but just decompose on other operators, Sparkle operators, that is. Then second is I presented at the Solid Symposium. I presented Incremunica there, and together with that in Incremunica, I did some repo cleanup because Tom Windels, one of our colleagues, was using or was trying to develop it in Incremunica and find it really difficult. So I did some repo cleanup and like some better readmes and so on, better documentation. And of course, I made a logo. And this is all for the press tour that is coming up, where I'm presenting Incremunica at Solid Symposium and at ESWC. And then finally, also for this reason, I migrated the Solid Watch Party that uses Incremunica. I migrated that to Incremunica version 2. It's not merged yet, but it's almost done. So yeah, and then next targets are preparing the slides for ESWC, where I'll be presenting, of course, the decomposition paper and the Incremunica paper. I guess the slides for the Incremunica paper are almost done because I already presented them at ESWC, at the Solid Symposium. And then finally, I'm working on the aggregator journal paper, and for that I need some use cases. I think I'll start on creating a binding for the Elevate project. It's an open source code base for looking at fitness data. And yeah, it's a nice dashboard with analytics and so on. So it's actually a low effort way to having like a solid application in that with a nice UI and so on. So it's low effort and I think pretty nice. And that's why we actually chose it as another use case for solid and the aggregator in the end. Yeah, that's I think mostly it for me.
When you say solid binding, what do you mean by solid binding?
So right now it uses Strava, if you know what that is. Elevate uses Strava as a backend, as like, I guess it's data pod for people, but it's not really because it's centralized. So using a solid binding, I mean, instead of using Strava where the data is located, use solid as the place where the data is located.
What type of data is it? Because if it's fitness data, I'm assuming there might be some streams, or is this just, what kind of data is it?
So it was a stream, but it's all nicely packaged into a nice window for me, where the window is just the time you exercised. So it's just a file that represents your whole thing that you did, your whole activity.
Okay, thanks.
Right.
I'm wondering, with the solid binding, do you have extra functionality that come with it, or it's mainly about the privacy, or there is something that are more easy to be done now?
So yes, but currently, of course, no. The main issue in this space is, and I actually have this issue personally, where you have a lot of apps that actually use the same data, but they are not really communicating. All of them use Strava, and like Strava is actually like kind of your pod. So Garmin like figures out the data and like records the data and then pushes it to Strava. Strava then distributes it to Elevate and to Join maybe, or all kinds of apps that all do different kinds of things with it, but they're not really it's working together. It's like Strava is kind of your pod in that sense. The main issue with Strava is they are you need to not really pay for them, but if you don't pay for them, the API is really slow. And if you then use Elevate, for example, it takes often like multiple minutes for all the data to actually be uploaded to it and for you to actually see all this dashboard. So it's not really a fun user experience. So Solid in that sense could actually greatly improve your user experience.
Yeah, I see. Thank you.
Okay. In the interest of time, let's move to Jitse.
Yes, so my high-level goal is optimizing write performance in decentralized personal data ecosystems. So I look at writing in Solid, for example. Next, what I worked on first was the storage guidance framework demo, which is now also public. So it's basically the demonstration that I will give on ESWC. And I needed to tweak it a little bit to make it public, and that took a while, instead of just hosting it on your local host, on your local machine. Secondly, writing a paper on modular parser for the semantics workshop. So I've been working for a while now on Dracula, and I want to write a paper regarding the modularity, so that you can basically just take a grammar rule, swap it out for another grammar rule. Then I prepared the logistics for my research day at the Technical University of Vienna. Asking for funding, sending mails back and forth to my host. So that's that. And then round tripping, I looked at the round tripping in Dracula. So this has also been talked about in previous months, that we want to have a query, then generate an AST, and then from that AST, if we generate a query again, we want it to be the same query as to allow, for example, linters and live translations. There were use cases. Yes, but the idea of this round tripping that we currently had is wrong. So I decided to try again. Well, now I properly looked at how Babel does it, and so we will try the Babel approach, which is less tailored to the grammar itself. I guess that's enough information for that. My next targets are, well, preparing for ESWC, since I have a demo paper accepted and a PhD symposium accepted, so I have quite some work to do there. Then I want to continue writing the paper for semantics, and the deadline is in the middle of June, but the first 2 weeks of June, well, there's ESWC and ISWS, so it needs to be done this month. And I want to write a vision paper about the interface data description, which I've also talked about in previous months, where I want to relate read interfaces towards the writes, and like just in general describe the relationship of interfaces towards the underlying data. And I want to submit this vision paper to the HyperAgents workshop, which is in end of October, I think. But the deadline there is also the middle of June. So busy with writing. And that's it.
Okay. Any questions for Jitse?
I should do it fast.
Yeah, very good.
No, just the encouragement to submit to a HyperAgent workshop. Of course, I am biased here.
Yes, I have to do extra hard. I have to do my best. I don't know the English. I'll try.
You'll manage. Yeah, I guess the paper for semantics is almost done, so
It depends on how much our conversation in a few hours says that needs to change.
I guess it's mostly done, and then you have all of the remaining time left for the HyperAgents.
Yes, and I'm now heavily discussing this work with Ruben Eschauzier as well.
Okay, very good. I think we had everyone. Yes. So some a small announcement I want to do. I think most of the people here already know about it, because Jitse is one of the people who will submit there. But we have a developers workshop at the Semantics conference later this year in Vienna. So if you have any cool software related to semantic web or knowledge graphs that you want to show during this workshop, if you want to give a talk or just a demo, or you want to propose some specific topic you want to have a discussion on, be sure to submit to this workshop. Deadline is the 14th of June, so not that far off anymore. All right. So the next progress update will be on June 17. So the schedule is shifted slightly due to upcoming holidays and overlapping things, but it will again be on a Tuesday at 9:30. All right, I think that's about it for today, unless anyone has any other comments or announcements or general questions. If not, thank you all for joining, especially Fabien for joining us, and we'll see each other again on June 17.
See you in June. Thank you for the invitation. Bye-bye.